folks, today we're going to talk about percent error. So percent error is a way of telling how close or how far away your answer was to the real answer. One of the struggles we have here is depending on what you're guessing, the same amount of error, the same difference from the right answer could either be really good or it could be really terrible. If you are trying to guess my mass and you get my mass to within 20 kilograms, you did not make a very good guess. But if you're trying to guess the mass of an elephant and you get that correct to within 20 kilograms, that's pretty deeply impressive. If you're trying to guess someone's height and you're off by a foot, that's not very good. But if you're trying to guess the distance between here and LA and you get that exact to within 1 foot of the correct answer, that's deeply impressive. So how far off your answer is from the truth could be really good or could be terrible, depending on the scale of the thing we're measuring in the first place. And that's sort of the problem that percent error is meant to solve. It lets us tell how good our answer was in comparison to the actual size of the thing. So the way we calculate percent error is pretty simple. You start out by figuring out what your error is. And error is just a word that means, hey, how far was your answer from the truth? So error is just how far your answer is from the truth. So when you're trying to find percent error, what you would do is you would start by saying, okay, how far off is my answer? If the correct answer to something was 25 grams and you said the answer was 20 grams, you have an error of 5 grams. If the correct answer was 25 grams and you said that the answer was 30 grams, you're still 5 grams off, even though it's in the other direction. So with error, we always take what's called the absolute value of it, which means we just take that number, we make it positive. We don't care if we undercounted or overcounted, we just care how far away we were from the truth. So we start with our error, and then we're gonna take that error and we're gonna put it in the context of how big the actual thing is that we're measuring. So you'll take your error and you would divide by the actual value. So in this example, if I have something where I said it was 30 grams, but it was actually 25 grams, I was off by 5 grams, I would take that 5 grams, I would divide by the actual value. So I'd say, okay, what's 5 divided by 25? I would get 1/5 or 0.2. And I would take that 0.2 and then I would multiply that by 100. And what multiplying by 100 does is it literally just turns it into a percentage. So you take your error, you divide by your actual value. When you multiply by 100, multiplying by 100 just turns it from a decimal into a percentage, and that's your percent error. So in this example where I said it was 20 grams, but really it was 25, I was off by 5 grams, so I take the amount I'm off by, I would divide that by the actual answer, which we said, oh, the truth is it's actually 25 grams. I divide that out, so 5 divided by 25 is 1/5, which is 0.2. And then I multiply that by 100 to turn it into a percentage. So 0.2 times 100 is 20%. What that means is that my guess was off by 20%. So with percent error, if you get it exactly correct, if you were 0 grams off, if I said something was 100 grams and it actually was 100 grams, my error would be 0. So then I'd be taking that error, dividing by the actual value, and regardless of what the actual value is, I'd get 0 as my answer. I'd multiply by 100, I'd still have 0. So a percent error of 0 means you are exactly correct. If you had a percent error of 100% error, that would mean that you literally were off by the amount of the thing. So if the answer is something is 25 grams, and I said it was either 0 grams or 50 grams, if I was off by 25 grams, I would end up with a percent error of 100%. This does mean that it's possible to have a percent error that's much bigger than 100%. Broadly speaking, you are hoping that your percent error is a small number. Now, in our inertial balances lab, you are going to be calculating the percent error of what you figured out using your graph, not your hypothesis, using the graph itself. You're going to be taking that number, you're going to be comparing that to the actual mass of our unknown. And I will let you know how heavy this thing actually is the day after we've all done our graphs. So I'm not going to give you the mass of this until after you've all used your graphs to find that actual value.